So in this section, we're going to be talking about surface area. So with that, we're going to be analyzing three-dimensional figures. And this can be kind of difficult to do, especially on a piece of paper that is two-dimensional. So with that, we'll just have to kind of stretch our brains a little bit to try to visualize these three-dimensional pieces, or things like this, like a rectangular solid. If you find like a box of pasta or something in your kitchen, you can grab one of those to kind of visualize all these different sides that we're talking about. So what we're going to look at here is this application of a cheerleading coach, and they're going to be building these boxes. So this is a rectangular solid because it's all made out of rectangles. So we have these different sides, and with that we end up with a description for length, width, and height. So in this series, we'll talk about the surface area. In the next series of videos, we'll talk about volume. So surface area is all about the area that's along the outside of the shape. When we talk about volume, that's going to talk about the space that's taken up inside of the box. So surface area is kind of outside, volume inside. Something to note is that when we deal with area, when we calculate it and find our units, it's going to be squared units. So whatever units we calculate with, they'll be squared. When we go to volume, they'll be cubed, so they'll have an exponent of 3. But this will be important for when we get our calculation out and correctly identifying the units we're dealing with. Okay, so we have this rectangular solid, and we're looking at, like I said, length, width, and height. So the length of the box is going in this direction. So this is 4 feet for the length of the box. Width of 2 feet. So that's going to be kind of like the depth of the box. So that's going to go in this direction here. So that'll be 2 feet for the width. And then the height of the box is going to be how tall it is, and that's going to be 3 feet for the height. And we want to find the surface area. So with this, and as you can see down below here, we have a formula, but I'm just going to talk about, like, what if you don't remember the formula and you need to find the surface area. With this one, it isn't too bad to visualize. So if we think of our rectangular solid, so we have our rectangle and it goes back, it drops down, and then I'm just going to show how it kind of comes through in the background too. What we end up with are these pairings of kind of same areas, meaning we have this front panel here. So let me shade this in. We have this front panel. Like in the picture up above, that's where we're seeing that varsity cheerleader written out. That same panel occurs in the background as well. It's at the back of the box, back here. Sorry, I know, again, with a three-dimensional figure, this is kind of hard to visualize, but it's also happening back there. So those two rectangles have the same dimensions. It's dealing with the length, and same thing up there, and the height. So we have these two rectangles that dimensions are length and height. So what we could do is one of those rectangles is taking L times H, but then what we want to do is have two of them. So I'm just going to go 2 times L times H. And that takes care of 2 of the panels. Now, that takes care of the front and the back. Let's talk about the top and the bottom. So there's the top of the box, which is up here. And then there's the bottom of the box, which would have the same dimensions. So these two are going to use the length of the box. So we're going to have length and length. And then the other side of that rectangle is coming from the width of the box. Width, width. So what we could do is think of this as one of those rectangles is taking the length times the width, and we have 2 of them. So for the total area of those 2 rectangles, you take length times width plus length times width, which just makes 2 of them. All right, so with those, we've covered 4 sides of the box, but there are 6 total sides to our box, so we need 2 more. And that's coming from the sides. So we took care of front and back, top and bottom, and now what we have are these kind of square-ish looking sides here. So you have the left side and the right side. Now, in terms of side lengths, this is being made up of the width of the box and the height of the box. So what you could do is take width times height, and then we just double it because there's 2 of them. And that takes care of all of the sides of the box. So if you kind of deconstructed the box, we would have 6 panels. You would have the front, the back, the top, which is just a rectangle. I'm just slanting it to kind of match how we're seeing it in the picture, top and bottom, and then right side, left side. So what we've done is we've accounted for all of those areas, and then if we want the total surface area, we just add those up. So with this, even though we have this formula down here, which is exactly what I just found for us, you can also deconstruct it and just kind of break it apart into these separate rectangles, as long as you make sure that you have all 6 panels in the end. Then maybe you'll have a question where, I mean, this doesn't work for cheerleading because they need to stand on the box, but say we have a scenario where they actually want the box to be open, then what you would do is just take away one of those top calculations, like where that's taking length times width. You just get rid of the 2, and you would only have one of them to account for the bottom of the box, but then that would leave the top open. So you can kind of play with it in terms of how many sides you have, but it just comes down to a bunch of calculations of area for rectangles. Okay, so let's actually calculate the surface area for this rectangular solid. So what we're going to have is length times width, so that's 4 times 2, and we're going to have 2 of those. So I'm going to go 2 times 4 times 2, plus, so that takes care of length and width paired together. Then I would have, so I'm just going to go, I did those 2 together. We could have 4 times 3, and we'll have double of that, so 2 times 4 times 3, plus, and so that takes care of that pairing. So the only pairing I have left is 2 times 3. So we're going to have 2 of those, 2 times 3. So notice I didn't follow the exact order of length and height, length and width. The order doesn't really matter. What matters is that you account for all of the panels. So let's see, 2 times 4 times 2 is an 8 times 2, so that's 16. 2 times 4 times 3, so 8 times 3, 24. And then 2 times 2 is 4, times 3 is 12. And then we're just going to add that together. So let's see, that's a 40 plus 12, so 52. You could also just go ahead and throw all of that into a calculator at once and get you to that answer. And while it looks like we're done, we're not quite done because we need our units. So again, this is area. So what we're going to do is take feet squared, because it's all about these square units that are showing up along the outside of the box. And we want to know how many of these square units do we have. All right, so that's our calculation for surface area. We have a rectangular solid with length, width, and height. If you have a cube, which means all of the side lengths are exactly the same, then what you would have is you have these squares. So that's where the s squared is coming from. It's like s times s to get those dimensions. And then the idea is that you would have 6 of them. So you would have front and back, top and bottom, left side, right side. So you have 6 of those squared units. So it's a little more direct there.